Do you want to know how to create a deep clone in TypeScript? Watch this video to find out. Hello and welcome to part 27 of the series on how to create a chess game with Reactjs. In this part we are going to create a class for the chessboard. In our source folder we are going to open up the models folder, and right here we are going to create a new file named chessboard.ts, and this file will be a class export class chessboard, which will contain an array of pieces or a list of pieces. So we say pieces, which is a piece array. And then we also want to create a constructor for the chessboard. So we say constructor, and then we open up the brackets and we close them. And inside of this constructor, we want to assign this property of the chessboard, because we cannot leave the constructor without assigning the property pieces. So we say this.pieces is an empty array, and instead of making it an empty array, we want to pass it through the constructor. First, we are going to import the piece type or the piece class, and then we want to say that we expect an array of pieces as a parameter in our constructor. And this array of pieces is what we are going to assign to this.pieces. So now we have a chessboard model which has a property named pieces and a constructor for assigning the pieces that we pass in the constructor. We want to use this chessboard, so we are going to open up our constants, and inside of here, instead of creating an initial board state, we are going to create our chessboard. We are going to rename this to initial board, and this won't be a piece array anymore. This will be a chessboard. As you can see, we automatically import it from ./models/chessboard, which is fine. And then instead of assigning it to a piece array, we are going to say is equal to new chessboard. And then we open up a parentheses, and at the end of the file, we want to close it. So right here, we close the parentheses. And what we did right now is we have called the constructor of the chessboard. And inside of this constructor, we pass an array of pieces, which are all the pieces that we have defined right here. And then in the chessboard, those pieces will be assigned to the pieces of the chessboard. Now that we have a container for the pieces, we can also add more things to our game, like saying whose turn it is to move, or for example, keep track of how many moves have been played. Before we are going to do that, we need to fix the compiler errors. So in our components, in our referee right here, we get an error because we cannot find the initial board state anymore, which is true because we renamed it to initial board. And then down here we have the piece state, which has the pieces and also the function to update it. We pass in the initial board state. So this will be the initial board, but the initial board is not of type piece array, it's of type chessboard. So right here we want to say chessboard. And then we might get an error because we have a duplicate identifier. So we have a component named chessboard and also a model named chessboard. So let's rename our model to board. We get the question if we want to automatically import or update the imports. We don't. We are going to do that manually. So right here we renamed this class to board. Here we will also rename this to board, and up here will be a board as well, and right here as well. We don't need to explicitly say that this will be of type board, because right here we already call the constructor of the board. So we can remove this, and if we hover over here, we get the any. Okay, so it seems like we do need to specify that this is of type board, which is fine. So in our referee, we can import board from models/chessboard, which will be board. And we also need to change that right here, like so. This won't be a chessboard, so this will be a board. and right here we still have our initial board. So now that we fixed those errors, we want to rename this to board because we no longer have a list of pieces, we have an actual board. So we say board and setBoard. Well, and then we're going to walk through this file and we're going to fix the errors one by one. Here we want to update the possible moves. So we updated all the pieces. We are going to move this functionality inside of the chessboard. We are going to cut away this code and then we want to call a function on the board. So right here we say board dot, and then we are going to call our function calculate all moves. And this obviously is not a function on the board yet, but if we open up our board, which is up here, and we create a function calculate all moves, which doesn't accept any parameters, but that's fine. We can paste the logic that we have just copied over, which is the logic for updating all the pieces. We want to remove this outer part of the logic. Then we want to automatically format it. We're going to remove that white line and we return something right here. We don't need to return anything. What we want to do is we want to update the pieces that we have inside of the board right here. So inside of here, we want to say for const piece of this.pieces. And then for every piece, we want to say piece.possibleMoves is equal to, and then this function, getValidMoves. We're going to copy over this and put it right here. And then we can remove this piece of code. Now, obviously, we don't have the getValidMoves function, which is fine. Right now, we are going to assign it an empty array, like so. And inside of our referee, we get an error because we misspelled calculate. So we say calculate all moves. So we have this working again, even though we are not assigning any move to our pieces. We will do that next. But first, we are going to fix the next error. So we have updated pieces is equal to pieces.reduce, and then we pass in the results and each piece. So what this does is it updates the pieces array by applying some logic and also removing pieces where needed. Instead of doing this right here, we want to do this inside of our board. So we want to move this logic inside of the chessboard. So let's see. We have a parameter right here to check if it is an ampersand move. And then we use the pieces. We use the piece. The plate piece is also one that we need. All right. So let's select everything till down here, right here. We can remove this. We're going to save this up. And then right here, we say play move. And we paste the code that we had right here. This function will obviously return a boolean because right here the play move also returns a boolean, and we need to get that boolean from the board right now. It needs to know if it is an ampersand move, so that will be a parameter that we expect, which is a boolean. Then next we are reducing the pieces. We already have the pieces, which is this.pieces. Then the next thing is that we don't know what the pawn is. We can import it from dot/pawn. Then we have something about the destination. That should be a position, I think. So we're going to import, or not import, we're going to request it as a parameter right here. Destination, which is a position. And we also import the position from dot/position. Then we have the plate piece. Plate piece is a piece, I guess. So right here we say plate piece, which is of type piece. And let's see, we already imported that one, I think. Yeah, because we have a piece array inside of our board. Then down here we have update possible moves. If we go to here, the update possible moves function is calling the board.calculate all moves. So what we can do right here is say this.calculate all moves. And then we set the pieces to the updated pieces. We don't need to do that anymore because we immediately update the pieces when we do that. Actually, we don't immediately do that. We still need to assign them. So we are going to say this.pieces is equal to this.pieces.reduce. Then down here we have else if it is a valid move. So we expect another parameter, which is valid move, a boolean. Then we want to update our pieces as well. And instead of updating them, we're going to say this.pieces is equal to this.pieces.reduce. Then down here we have, let's see, a piece type. All right, so the piece type will be an enum. We can import that from our types. Then down here, the theme type will be also an enum, so we can import that one as well. And we get something about a model ref. Also a promotion pawn, and then down here, we update the possible moves again. We are going to replace this with calculate all moves. We also did that up there. And then we set the pieces, which is something we don't need to do anymore. So now we have filled in everything. We still have a couple of errors. The first one being the pawn direction. Then we have a boolean on top, which we expect to return. And then down here, something about a model ref. So first of all, the pawn direction. I think that should be a number. So let's look right here. Do we have a pawn direction? Yes, it will be 1 or -1. So the pawn direction is something we can also calculate inside of our board. So we can move this up here. So we don't need to pass it in as a parameter. That will fix the pawn error. Then we expect to always return a boolean. But this function doesn't always return a boolean. In the if statement, it will return nothing. In the else if, it will also return nothing. And in the else, it will return false. So let's say that we want to return true in the if, and in the else if, true as well. Because this means that the boolean that we return will be true if we can play the move, and it will be false if we can not play the move. So if we look up here, we also see that we return true by default. So we are going to copy over that. We can remove the trues right here. And then down here, we return true by default. It's another way of writing if we can play the piece or not. It doesn't matter which implementation you use. Instead of determining whether to show the model for the promotion or not right here, we are going to move that inside of the referee. So we are going to cut this piece of code right here away with the promotion row actually. So we're going to cut this piece of code right here. Then we're going to save this up, and inside of our referee, we're going to put this. So we're going to format it, and we see that promotion row is equal to piece.theme. And then instead of getting the theme from the piece, we want to know the theme of the played piece. So we say played piece.theme. So if the piece that we played is on our team, the promotion row will be 7. If it is on the enemy team, the promotion row will be 0. Right here, we check if the destination is equal to the promotion row, or at least the Y destination, and if our piece type is a pawn. This is something that we can improve. Instead of checking if the piece type is a piece type of pawn, first we want to say that this will be the played piece. And then instead of saying is the type equal to piece type.pawn, we can say is pawn, which will call this function, which we have created in a previous episode. which will return true if it is a pawn, and it will return false if it is not a pawn. Then we want to show the model, and we want to set the promotion pawn, not to piece, but to plate piece. Yeah, like so. Now that we have fixed this piece of code, all we need to do right now is call the play move on the board. So we say board.playMove, and then we need to pass in some parameters. The first parameter being the ampersand move, and let's look at the board again. We expect the ampersand, valid move, plate piece, and a destination. So we say ampersand move, valid move, plate piece, and the destination, like so. And we are going to wrap this in some multiple lines so we can read the parameters that we pass in. Now, if we save this up, we don't need to touch this piece of code for now. We are going to work our way down right here, which checks if the piece is an ampersand move. So we are looking inside of the pieces. We can easily just say board.pieces, which will fix that error. And then down here, we get errors because we don't know what the pieces are. We're going to press Ctrl D a couple of times, and then we can say board.pieces. By pressing Ctrl D, we can select the next occurrence of that word, and it will also add a new cursor where you can write, so you can write on multiple lines at once. Right here, we can say board.pieces again. And then down here, we don't need to set the pieces to the updated pieces. We will be calling the board.pieces is equal to this. So board.pieces is equal to board.pieces.reduce, something we already did in the board just now. And then right here we pass the pieces. Now that we fixed those errors, let's save it up and refresh the page. We still get a page, which is good, but I suppose it's not fully working. Well, actually it is, but we don't see the possible moves anymore. Also, one thing we noticed is if we go and capture a pawn, black will always win, which is fine if you're black, but if you're not playing as black, then you might not have a fair advantage. So for now, we are going to first of all fix that we can see the moves again, and then we are going to work on fixing the logic for capturing pieces. So the moves are being calculated inside of the board right now. So if we go inside of here, we see that we have a use effect when we start the application. And then we also have a function update possible moves, which calculates all the moves for the board. And this will also be called when we, for example, promote a pawn. And inside of our board, we call the function to calculate all moves when we play a piece, right here, and not down here. So what does this function do? For now, it's doing nothing. Before, we had a function which we called, which was getValidMoves. Inside of the referee, we still have that function. So we want to remove that from here, save up the referee, and then right here, inside of the board, we want to paste the function getValidMoves. So here we return a lot of positions, I guess. As you can see right here, the return type is a position. And we return that by calling a function right here. So we can import them inside of here. And once we have imported them all, we will get some moves again. But before we will get them, we still need to call it on this position where we want to assign the possible moves to the pawn. So here we say getValidMoves. The piece where we get the moves from will be the piece, and then the board state will be this.pieces. So instead of board state, we could also use the name pieces right here, but we'll leave it at board state for now. So if we save this up and refresh the page, we should see some possible moves appearing, which is great. But however, if we take an enemy pawn, our knight will disappear. So why is this happening? If we look inside of the referee, we are going to look at the beginning. We play a move, check if it is valid, if it is ampersand, and we play the move. Okay, so we pass some parameters, and then we do something for the promotion row. So this will only be when we have a pawn promotion. So right here, let's add a comment. This is for promoting a pawn. And while we're at it, we can also add a comment right here, playing the move. So right here, we play the move. Let's look how we do that. Well, first of all, we determine the pawn direction, which is fine. Then we check if it is an ampersand move. Well, in this case, if we take this pawn, it's not an ampersand move. So else if it is a valid move. That's true, it is a valid move because we can move there. As you can see, there is a circle around the pawn, so it means there is a valid move. And we can also move our horse around, but that's fine. So right here, we check for all the pieces, and then we apply some logic. Let's scroll down to the right a little bit more, just a little bit further. Then we see if the piece is the play piece. So this means, do we have the piece that we are currently playing? Piece that we are currently moving or playing. It's basically the same. The play piece is a piece that we are moving or playing, and then right here we check if the piece that we are looping through, or the pieces that we are looking through, is the same as the play piece. Then we know, okay, this piece will be the piece that we are going to move. Here we check if the piece is a pawn. Well, in our case, it's a horse. And what we then do is we push the position of the horse into our piece array. So that means that the horse should be alive. So let's check this out, move the horse to there. And we do get some weird functionality, because when we move the pawn, we see that the horse is still appearing right here, but then everything just breaks for the pieces that we have moved once. Let's open up the console. Do we see any errors right here? Well, we don't, but there are some errors. Well, not exactly errors, but there are some things happening which are not correct. So we definitely push the horse back, as we can see right here. We say results.push piece, and then right here we say, okay, if the piece is not the same position as our destination, what we can say right here is just say destination, because destination already is a position. So we're going to remove this and say destination. All right, so we can also remove one parenthesis if our piece is not the destination piece. So let's get the situation back. This piece has already been handled if we move it right here, because that's this piece right here. Then if we move this piece, we are going to get into this method, because we already moved the horse. Then here it checks, okay, the piece that we are at right now, is that the piece where we want to move to or not? So in this case, that's all the pieces except for the pawn where we want to move to. And what do we do with those pieces? We return them. So we push them to the array. All right. And otherwise, so this will be the piece at the destination location won't be pushed in the results. So otherwise, we have a piece which is at the destination. It's this pawn right here. And that pawn won't be pushed inside of the results. As you can see, if we don't execute this line of code, we only return the results. So then the pawn should be obliterated, or at least removed from the game. But that's not happening, because our horse gets obliterated and the pawn can just freely move, and then the game is all wacky. But how is this possible? Because we do update our pieces, and then we also calculate the moves again, and then we return true. So how is this happening? If we go inside of here, we have the board which is playing a move, and this board modifies the pieces, which means that we want to update the UI, because this piece does not need to be shown anymore, and this piece needs to capture that piece. But the UI is not being updated. Why is the UI not being updated? Because we are not updating the state anymore. So if we go up right here, we have the setBoard. We are not calling the setBoard. We are right now modifying the board without calling the setBoard. And before we had a piece array with set pieces and the pieces. And if we set pieces, then the computer or the program knows that we are updating the piece array. And then it knows that it needs to re-render the page. But right now, because we are not saying setBoard, it doesn't know if anything has changed. So it still thinks the pawn is right here and the horse is also right there. All right, so in order to fix that, we simply say setBoard. Then we have a previous board. And then right here, we can return a value. So we can error because it is a value, it's never read, that's fine. That's, I think, a warning. But down here, we see that we have an error because void is not assignable to parameter of type setState action board. So if we return our board, it will go away. But we don't just want to return our board, we want to also play the move. So let's first play the move. And we are going to line it correctly. Then once we play the move, we want to return it. So the play move function, it modifies the board. So we're going to add another comment. We're going to put it above here. Play move modifies the board. Thus we need to call setBoard because we can only update the board inside of the setBoard function. All right, so let's refresh the page. We have saved up our file. Let's see how the project reacts right now. If we take the pawn, the horse is still gone and we can still move the pawn. So what's happening? Why hasn't anything changed? And this is a little bit more in depth of how the React setState works. If you'd like to figure it out yourself, go ahead and try it. The reason why this is happening is because we are not setting the board. Okay, so you might think like, huh, what? We do set the board because we play the move, we modify the board, and then we return it. That's true, but there is one big difference between modifying an existing object or replacing it with a new object. So what we are doing right here is we have a board, which is the state. The state consists of an object named the board, and inside of here we modify that object and we return that same object. So if we return the same object, React will think that nothing has changed because we return the same object. However, if we return a new object, then React will know, all right, the state has changed, I need to update the UI. So in order for React to trigger an update, we need to assign the value to something new. So in this case, we need to assign the board to something new. There are two ways. We are first going to implement the first method. Then we are going to also take a look at the second method. And don't worry that we are writing code that we won't use, because the code that we write will be used later on. The goal is to assign the board to a new object, but this new object needs to have the modified state, because we don't want to return the same board, right? We want to return a board which has this logic applied to it. One simple solution would be to make a copy of this board and then return it. If we create a copy of this board, then we have a new object which is exactly the same as the board right here. But because it is a new object, React will think, hey, the board has a new value, a new object, then it will trigger an update. For creating a clone or a deep clone or a shallow clone, there are multiple methods. The method that we are going to use or do will be the manual method. So inside of here, we're going to say board.copy. And then it will return an error because copy does not exist on type board. That's true because we are going to implement it all by ourselves. Right here, we're going to create a function, copy, which will return a board. And then right here, we want to return a new board. So we say return new board. And this board expects some pieces, which will be this.pieces. If we save this up, we don't get the error anymore. And inside of here, we return a copy of the board. So what actually happens right now? We have our board. And this board is the board with the modifications, because we have played a move. The board with the modifications will be copied. So we call the copy function. The copy function will return a board. And the board that we will return will be a new board, which contains this.pieces. So this new board is actually a board which has exactly the same pieces as the board that we are in right now. So to further clarify what we are doing is we are going to write it out for now. Const board clone is equal to board dot copy. Right? And then we want to return the board clone. So here we have a board. This board will be copied into this value or this variable. And then we want to return this variable. So inside of our copy, we return a new board with this.pieces. What we could also do is return this. Okay, and I'm not trying to make it more complicated than it is, but if we return this, what will happen is we will return the board that we are currently in, which is not what we want, because we want to create a new board. With the clone, we want to create a whole new board which has no references to this board. So we don't want to do anything with this board, which is why we say return new board. And then right here, we pass the pieces. I can already hear you thinking, but the pieces are also objects. Don't we need to clone them as well? Yes, we are also going to clone the pieces. Because just as we showed up here, if we just return this, then it will make not a real copy of the board, but we will just be returning the existing board. The same goes for the pieces. If we say this.pieces, we won't be making a copy of the pieces, but we will just return the same pieces. So we can remove this and we can replace it with this again. And what we want to do is we want to create a new array with completely new pieces. But those pieces need to be exactly the same as the pieces right here. So we say return new board, this.pieces.map, and then we go p is equal to, and then p.clone. And we can close it off with a semicolon. And we're going to break it down once again. So first of all, the clone does not exist. And second of all, we are using a map function right here. So before we are going to write this, we are going to write it out a little bit more easy. So we say const cloned pieces is equal to this.pieces.map p.clone. All right, so right here, we have a variable named cloned pieces. And this cloned pieces variable will be equal to the pieces inside of this board, but then mapped to this. So how does this exactly work? The map function loops through all the pieces and then it applies some logic to that piece. So we have already used that before. Say for example in the calculate moves function, we are going to navigate to there. We don't use a map, but we use a for each loop. All right. So what we could also do down here is instead of, let's scroll down. No, it was in the board. Let's scroll down. Instead of mapping the pieces, we could also loop through the pieces. So let's comment this out as well. And then we say const cloned pieces is equal to an empty array. And then for const piece of this.pieces, cloned pieces dot push piece.clone. So this will be the version, the somewhat longer version of this. So essentially it's doing exactly the same, but it's just written differently. Let's try and implement this first, and then we can continue on to the more complex scenarios. So first of all, we need a clone function of our piece. So right here, we say clone, which will return a piece. And then right here, we want to return not this. Remember, if we return this, we do not clone the piece. We just return the same instance, but we want to return a new piece. And then this new piece will have the same parameters as, let's see, the parameters will be this.position, this.type, and then this.teamType, which will be this.team. So we can move those into a new line. And then right here, we have a new piece. Great. We also have a list of possible moves, but for now, we are not going to copy over those. We are going to do that after we have created a base copy for everything. So we have a position, a type, a team, and the image will be calculated based off that. All right, so we have the clone function on the piece. If we go inside of our, not the referee, you can save this and close it. If we go inside of the board again, we see that we have a working function right here. So we can remove this. And we are going to create a const cloned, no, not the clone board. We're going to create a return new board. And this board will have a piece array of clone pieces. So instead of saying this.pieces, we want to use the cloned pieces. So if we save this up and refresh the page, we can move the horse, but we don't see the possible moves anymore. So let's move it once, and then the possible moves are gone, which is, well, that's because the positions are not being passed on, but for now it's okay. And if we take the spawn, we see that we can take it again. We can take it and we can move again. All right, so let's first of all try and get our possible moves back, because we really would like to see where we can move. To get those back, we can add it to the piece array or the piece constructor. So right here, all we pass in a constructor is a position, a type, and a team. But what if we already have a list of possible moves for this piece? Well, if we already have a list of possible moves, we want to be able to pass it in. So we say possible moves, which will be a position array. And then right here, we say this.possible moves is equal to possible moves, like so. And then down here, we can say this.possible moves. And now we pass the possible moves of this piece as a parameter to here, so that the new piece will also have the possible moves from its parent or from its caller, so to say. We also get an error inside of here, but that's fine. Right here, we don't know what the possible moves are yet. So we don't want to need to pass them in inside of a piece. In order to fix that, in order to make the possible moves not mandatory, we are going to assign it a default value, which will be an empty array. Now, if we refresh the page, move the horse, we see that we have our possible moves back again. But there is one thing that we still need to do, which is we are going to make a clone of the possible moves instead of using the possible moves. So why all this cloning? We already cloned the board, the pieces, and now also the possible moves. Why are we not cloning the team? Or why are we not cloning the type? That's because the team and the type are not objects inside of JavaScript. They are value types. The possible moves are objects that we have created ourselves. They are of type position. There is a significant difference between a value and an object in JavaScript. So in short, objects are reference type variables and values are value type variables, which means that if you assign a value to another value, so for example, you have a number and you assign it the value 3, then that will be a 3. And if you assign it the number 5, it will be 5. But for an object, if you assign it to another object, it will not get the value of that object, but it will point towards that object. It will be a reference to that object. So right here, if we pass the possible moves from this piece into our new piece, then instead of having new possible moves inside of our new piece, we have a new piece, but the possible moves of that piece will be from this piece. And that is because objects are references, so or reference types. So if you have an object, it will be a reference type, and if you assign something to that object, then it will point towards that object. I'll put a link down in the description for you so you can read more about this. But in short, we are also going to create a clone function for the positions because it is also an object. So up here, we are going to create a function clone, which will return a position. And then this will be this will return a new position. We could also return this, but then we get the same object. So we want to create a new position, which is of this.x and this.y. And now we have completed the clone chain because we are not dealing with objects anymore. This.x, this.y, those are numbers, and numbers are value types instead of reference types. So they will have a new instance of themselves. Instead of pointing to this position, they will be pointing to the new position that we create right here. So let's roll it down from the top. In our referee, right above here, we clone the board. So we say const board clone is board.copy. This copy will return a new board right here. And this board will also have new pieces. So that will be the pieces from this board, but then cloned. So they are really a new piece. And inside of the clone of piece, the piece will have its parameters, so the position, type, and team, but also the moves, and it will have new moves instead of the moves that this piece has. So it's all new. Every object has its own properties instead of pointing to another object's properties. So let's save this up for now. And we are going to create a more complex situation right here, which is shorter, but it's also a little bit more complex, as I said. So instead of creating an array which holds the clone pieces, we want to use a map function. So instead of looping through them, we are going to do that right here. So we are going to uncomment this, and then we are going to copy over this right here. We are going to move this to up here, and then we are going to remove this construction. And what we have right here is also a variable named clone pieces, but instead of looping through the pieces array with a for loop, we are going to map them. So this map function is essentially the same as looping through them. And then what we can do right here is we can access each piece. So this is the same as in the for loop, the const piece. And then we can do something with that piece. So before we said, hey, we want to clone this piece. Right here, what we do is we say we want to clone this piece, but then this piece clone is what is being returned to here. So instead of having to say clone pieces.push p.clone, the push mechanism is already being applied because we are using an arrow function. So we can even write it like this. So we can put a function right here, and then we say return p.clone, and then we return a new piece which will be cloned inside of this array. So we are going to stick with the arrow function, and then the clone pieces will be passed onto the board. We can even further shorten this down by saying this.pieces.map, by copying this over inside of here. Then we don't need to have a new parameter for the clone pieces. So right now, this should be the same as we have right here, because we have the same situation. Great. We can remove one of them. And then, let's see, inside of our referee, we also have a board clone, which is equal to this. And then we return the board clone. We can also immediately return this. And we don't need to assign this to a board clone variable first. All right, so let's test it out. If we move the horse, we can take pieces again. And if we move the enemy horse, we can also take pieces again. Even though this doesn't seem correct. So let's move the horse one more time. If we move it to there, then we get something which is not correct. In order to stop the pieces from not snapping back when you make an illegal move, we are going to create a let above here. Let played move is valid, which will be false. And then right here, I want to say played move is valid is equal to board.playMove, since the board returns the boolean if the move is valid or if it is not valid. And then right here, we want to return true if the played move is valid. So if we save this up, we can refresh the page. And then when we take the horse, we cannot move it onto another tile anymore, only on the legal tiles. Okay, I figured out what the error was. So right now, if we move our pawn to here, and we then take a horse, we see that we have a white pawn behind us. Or if we move with the horse to here, and we move back, we see that the white pawn is upon us. It took me some time to figure it out, but we have the solution. The reason why this is happening is because we are not creating new objects and because we are using reference types. So I made a mistake by modifying a reference type, which resulted in some weird things happening as we see in front of us. Settle your seatbelts, we are going to solve this problem. Inside of our chessboard, we have a function which plays the piece, which is right here or down here. Let's see, drop piece. Yeah, right here. So here we have a function which plays the piece, play move, and it passes the current piece as a parameter. This play move function is then executed on the referee right here, and then the played piece will be this piece. This played piece will be passed on to the play move function of the board. So if you go inside of the board, we get the played piece right here. Then what's happening is down here, we have a valid move. And if we have a valid move, we are doing one check right here, which is if the piece that we are currently at is at the same position of the played piece. And this is where it goes wrong. Well, not exactly. Those two lines right here, that is where it goes wrong, because we are updating the position of a piece. To make it more clear, we are going to write down the position of the piece. So we say console.log piece.position, and then we are also going to say same pos, as in we are at the same position as the played piece. Okay, so if we take this horse and we move to here, the position should be 1,7 because the x is 1, 0, 1, and the y is 7, 0, 1, 2, 3, 4, 5, 6, 7. Great. Now we are at 0, 1, 2 and 0, 1, 2, 3, 4, 5. So 2,5. If we move here, we see 2,5. Great. Now we are at 3,3, 0, 1, 2, 3, 0, 1, 2, 3. And if we move to here, we should see 3,3. But we see 3,3 and 2,1. How is this happening? We see the position that the horse was at, but also the position that the pawn was at. Which means that the horse will be pushed inside the new array, but the pawn will be pushed inside the new array as well. So how can this happen? How can the piece position change when we move a piece right here? So the piece position changes because, well, we update its position. So, well, fine, that's okay. But the thing is that if we look at the plate piece position, we should see exactly the same results, 1,7, 2,5, 3,3, and then 2,1. So the plate position, the plate piece position, is what's being updated right here, and the piece position as well. So both those positions are being updated from 3,3 to 2,1 inside of one loop through all the pieces. So how is this possible? I backtracked it. It took a while to figure out, but right here, if we are at the piece that we are playing right now, then we want to update its position to the destination position. But by updating the piece position, we update the position of the piece in this board. And by updating the position of the piece in this board, that means that every reference type, here we go again with the reference types, every reference type that is pointing towards this piece will also have its position updated, because it is a reference type, which means that it looks at the original piece. We do have one reference type or one object which looks at this piece. Okay, so we have on the board the piece array, right? That's simple. We have a piece array. But right here, we update the piece, we update the position if we are playing a move. Okay, so right here, we update the position, which means that up here, one of the pieces inside of here has an updated position. Now, if we go inside of the referee, scroll down to the chessboard, we see that we pass on the pieces from the board to the chessboard. So one of the pieces inside of this board has an updated position. Okay, so keep that in mind. If we go inside of the chessboard and we scroll up, we see that we get the pieces right here. And one of the pieces inside of this array has an updated position. Okay, so where is this being used? Let's look right here. We are in the drop piece function. What a coincidence. Okay, so here we check if the current piece, or what the current piece is. Current piece is one of the pieces of the chessboard which has the same position as the grab position. All right, that's fine. So this array is the array of pieces where one of the pieces already has had an updated position. So we have the initial piece. So let's reset this. So initially, when we drop our horse here, we have this horse right here. We drop it here. It will be 3,3. So the grab position will be 3,3. I added the log to clarify that. So right here, the grab position, if I drop it right here, will be 3,3, but we don't do anything because it's not valid. But as you can see in the console, the grab position is 3,3. So we are looking for the piece that has the same position as the grab position, which is the horse, obviously. Okay, so if we found the horse, we want to play the move. Then we go back to the referee with the current piece, and its current piece is the horse. And then up here, when we play the move, we have a plate piece. Okay, so this plate piece is the horse, which we have right here. And this plate piece is being passed on in a play move of the board. So we go all the way back here, and we have the play move right here. So this plate piece is the piece that we have right here, which is the horse. If we go down here to the valid move, we look through the pieces and we look for the piece that has the same position as the plate piece. Does this remind you of something? It should, because right here in the chessboard, we determine the current piece based off the pieces which has the same position as the grab position, which is the horse, 3,3. So we are looking for a piece that has the same position. So in our board here, we are also looking for a the piece that has the same position as our horse, 3,3. And then if we have found that piece, we are updating its position to destination.x and destination.y. So the updated position will be 2,1, 0, 1, 2, 0, 1, 2,1. Okay, this is all good. We update this position. But what happens is when we update this position, the position of the horse to here, what happens is inside of the chessboard, this current piece, which is also pointing to that horse, also gets its position updated to 2,1, which means that this current piece right here, which is being passed to here, which is being passed all the way to here, to the play piece, inside of the board play move. And then if we go back to the board right here, it's being passed as the plate piece as well. Down here, this position, the plate piece, that position also gets updated if we update this position. And I can prove it to you, because if we say console.log and then we want to log the piece position and the plate piece position after. If you just look at this piece of code, we are first logging the piece position and the place piece position. Then we are assigning the piece position, new position, and then we do exactly the same thing as we did up here. We also log the positions from the piece and the plate piece. So by only looking at this code, what you might think is that only the piece position will be updated right here, because only the piece position is being assigned. But what's actually happening is that the plate piece position is also updating, as we just figured out. We're going to save this up. We're going to refresh the page. And then we want to remove the loggings. So let's also go to the chessboard and remove this grab position. Then we go back to the board, refresh the page. We take the horse and we see piece position before, play piece position before, piece position after, play piece position after. The piece position has changed and the plate piece position has also changed. So as you can see, we are not only updating the piece position, but we are also updating the plate piece position. And right here, it doesn't matter a lot, because if we move the horse to here, well, at the plate piece position, there is no piece. So we don't care if the plate piece position has been updated. But right here, there is a piece. And because the plate piece position has been updated, that means that the pawn that was right here also has the same position as the plate position if it comes after the horse in the enumeration. And because it comes after the horse, that means that the pawn will go through this statement as well. And that the pawn will also get being pushed to the array as well, which is why we end up with two pieces. Now, the reason why we don't get this when we are moving with the white pawns, as we see the plate piece position is also being updated, is because the black pawns are being calculated first. So first we check for the same position of the black pawn. Its position was not the same position as the horse was in, which was right here. Then some pieces later we update the horse, because the horse comes later in the array. And then because the horse updates later, that means the pawn doesn't get the chance to go into this if statement anymore, because it already happened. And at the time of happening, the position of the play piece was not updated, because it happens after the pawn. The horse comes in the array after the pawn. So that's why this is just working normally and this is not working. But now that we know the problem, we can also find a solution. And the solution is not that hard. It will be a copy. Yes, you heard it right. We are going to make a copy. So right here, we are assigning the current piece to this. But when we want to play this piece, what we are going to do is we are going to say current piece.clone, like so. And now if we save this up, and let's also bring back the logging, because there is something magical, like so. And if we move this exact horse back in its position. We see that the play piece after is still being updated. All right. If we move this, it still is happening. So let's refresh chessboard because something might not be right. And I'm thinking I know why, because inside of the piece clone, the position is not being cloned. So we also need to clone the position. So now that we have cloned that, let's try it again. Voila. As you can see, the horse has a position of 1,7, or the piece position. The play piece has 1,7 and it also keeps 1,7. You see that right here? It's not updating to 2,5 like it was before. That is because of this and also this line of code. Because we are cloning objects, we are creating new ones instead of creating a reference to an existing object. Let's try this again. And as we see, we can freely move the horse without having any pawns attached to it. Amazing. So we are going to remove the logging again. Then what we are going to do is we are also going to apply the cloning part to the possible moves. So this is a possible moves. Map. And then inside of the chessboard, we have the current piece to clone, which is fine. One thing that we want to get straight is we are going to use one naming, copy or clone. We are going to keep it at clone for now. So we're going to say clone. And then right here, we also need to say clone. Save it up, refresh the page, and it should all be working again. Yes, it is. We can still play those moves, but not this move. I found out what the problem was, why we are not being able to ampersand anymore. So the reason why we cannot do that anymore is because when we finish playing a move, we go inside of the referee, and then we executed this function and we clone the board. But when we clone the board, we clone all the pieces. So if we go inside of the board right here, we return the pieces as a parameter, but we clone them. And if we look inside the clone function of the pieces, we see that we clone a piece, but if it is a pawn, we don't override the clone function. So the pawns will also call this function, which means that the pawns will also pass their position, their type, team, and possible moves, but not their ampersand boolean. So that will become null. We don't want that, so we say clone right here, which will return a pawn. And now we are overriding the function inside of the piece. Then we want to return a new pawn. And this new pawn will have this .position.clone. And then we have a team, which will be this .team. And then to finish it off, we also want to pass the ampersand. So we say this.ampersand. And then we want to be able to pass that in a constructor. So we say ampersand, which is a boolean. Now we can pass in the ampersand function and it will be a nullable boolean, right? We need to put it right here. So that arrow is gone. Then after we called super, we can say this.ampersand is equal to ampersand. We cannot say that before super because the error that we will then get is we need to first call super before we use anything with this class inside of the constructor. All right. So if we refresh the page and we try to take a pawn again, we can see that the ampersand move works as intended. Small thing that we forgot is to also pass in the moves of the pawn. So right here, we also want to say this dot possible moves. Then we need to make this a parameter for the pawn. And then we want to pass this on to our piece constructor as well. So now we can refresh the page. And then if we move a pawn, we see that we still get the possible moves. The reason why we can hit with our pawn on the first turn is because in the previous episode, we commented out all the ampersand references inside of our code. And we didn't bring back the ampersand reference right here in the pawn rules. So we say left piece as pawn, and then we need to import the pawn right here. If we save this up and try to move with the pawn on the first turn, we see that we can no longer move to the left, except if there is an ampersand. If there is no, we can not move there. And now we want to do the same for the right move. And now if we save this up, we cannot move to the left or the right, except if we can make an ampersand move. Alright, we made a start with creating a board model for our game. Inside of this board model, we can add so much more than only the pieces. And we also used this board model inside of the referee instead of the pieces array that we had. This will be it for this episode. I want to thank you for watching. I hope you could follow along. Leave a like, comment down below, subscribe, and I'll see you in the next episode. Bye!